Hello, welcome back. We're going to be continuing to solve fractional coefficients, equations that contain fractional coefficients. What if you had 3a divided by 5, 3a over 5, minus a over 2 is equal to 1/20th? Now, as I said before, here you have a fraction with an a and a fraction with an a, so you want to combine them together. That's what you want to do. And you have a 5 and a 2, so you could get a common denominator here, add these fractions, and then get the denominator to cancel, and so on. You could do that. But really the preferred way, the way that you'll kind of do it moving forward, is just what you really want to do is the enemy of getting this equation solved is really all these denominators. They really prevent you from adding anything until they all match. So really the fastest way forward and the most straightforward way is to multiply the left hand and the right hand side by some number, any number you can think of, that's going to clear as many of these denominators as possible, especially on the left hand side, because then that would allow you to combine the a's together. So let's just ask yourself some questions. What if I multiply by 5? Then I'm going to have this times 5, that'll cancel, and I'll have this times 5, that's not going to cancel anything because I'll have 5 halves. What if I multiply by 10? Well, then I'll have 5 divided by 10 is 2, and then over here I'll multiply by 10. I'll have 10 divided by 2 is 5. So by multiplying by 10, I should cancel both of these denominators at the same time. So that's what I'm going to do. What you'll have is 10, just open up a parentheses and just rewrite the problem. 3a over 5 minus a over 2. Now you do it to one side, you have to do it to the other side. So what you'll have is 10 times 1/20th. All I did is multiply both sides by 10. Now, we're going to take this 10 and multiply it by each term because it's got to be distributed in. So 10 times 3a over 5 minus 10 times a over 2 is equal to 10 times, I'll just write it as 1 over 20 for now. We'll do the simplification in the next step. All right, so now we start going down the line. We focus our attention here, and we see we have a 10 on the top and a 5 on the bottom, so we simplify it as we always have. We can divide top and bottom by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Then we look over here, divide by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. And then we look over here. Here we have a 10 and a 20, so we can divide top and bottom by 10. 10 divided by 10 is 1. 20 divided by 10 is 2. This is all fraction simplification. We've been doing this kind of stuff a long time. And now what we have left is 2 times 3a is going to give us 6a here minus 5 times a is just going to give you the 5a right here equals, you just have 1/2 left over. That's all that's left. Now, I agree it's not great that we have a fraction over here, but the main reason we did this was to eliminate all the fractions from the left. Because now 6 minus 5 is 1, so what we're going to get is 1a equals 1/2. And since a is by itself, that's the answer. Now you see how few steps that involved. It all boils down to trying to clear as many denominators at the same time from the left that you can. And that is why we multiplied by 10 on the left. So let's go and solve another problem, and you'll get the hang of it as we just work through some of these things. What if we have x over 5 minus x plus 4 over 7 equals 0? The problem again here is we have fractions on the left. We have variables within two different fractions. 5 and 7 are the denominators. What number can we multiply by to clear both of those fractions on the left, right? And you start thinking about it, and you go through your numbers and you realize, notably here, 5 times 2 is 10, so we ended up multiplying by 10. That cleared both of them. 5 times 7 is 35.